Alright, this was a test on set theory and probability. We're going to be working with Venn diagrams, cards, the probability of this given that, complement, union, intersection, all that good stuff. So problem number 1. Create a Venn diagram for the following scenario. Of the 189 teachers at Roswell High School, 110 teachers have a child. That'll be the C group. 95 teachers have a pet, and that'll be the P group. And 80 teachers have both. So we're supposed to make a Venn diagram for that. Alright, I'm going to use the pink circle to represent the teachers who have a child. So I'm going to put a C in here. And I'm going to use the blue circle to represent teachers that have a pet. So I'll put a P right here. And of course, this overlapping part is the set of teachers who have both a child and a pet. So let's start with that. They said 80 teachers have both. So I know that there will be 80 in here. Now, they said 120 teachers have a child. Okay, so that means this child circle needs to be a total of 120. This space out here represents the people that just have a child and no pet. So together with the 80, that has to add up to 120. So I need to go 120 minus 80. That is 40. Okay, so that means that there will be 40 teachers that only have a child and not a pet. So that's what goes out here, is the 40. So again, notice 120 teachers have a child. So these two numbers together add up to the 120. Now, 95 teachers have a pet. Well, 80 of them are already right here. So how many does that leave for the pet-only crowd? 15. Right? Because 80 plus 15 would be 95. So there you go. Now, how many total teachers are there? Because maybe this does not represent all of the teachers. And maybe there are some teachers out here in this zone who have neither a child nor a pet. So I got to look back. Okay, I see 189 teachers at Roswell High School. So if I add up all these three numbers, that's the total number of teachers we have represented so far. Okay, so the 80 and the 40, that's 120. And then 15 more, so that's 135. So this represents 135 teachers right there. But there's a total of 189. So I need to do, oh yeah, I remember. I need to do 189 minus this 135 to figure out the number that goes out here. Okay, that's 54. Okay, so it's going to be 54 teachers out in this zone. Okay, let me just clean this up. So here it is. Alright, this would be the Venn diagram representing this situation. If I add up all four of these numbers, that should equal the total of 189 teachers. Okay, so that's it for number 1. Publix did a survey of 60 shoppers and found that 37 people use coupons, 18 people bring their own reusable bags, and 8 people use coupons and bring their own reusable bags. Alright, so we got coupon users and reusable bag users. And of course, there's the overlap. Actually, I'm remembering now that the 60 was a typo. So let's pretend I didn't say that because this is 54. That should be 54. The reason why we knew it was an error is because these four numbers represent all of the shoppers in the survey. So these four numbers should add up to this total number. So let's just double check it to reinforce. So 29 plus 8 plus 10 plus 11. Okay, that is 58. Okay, so I'm glad I checked that, so it's not 54, it's 58. Alright, so now we're supposed to answer some questions about this. Let's start with A here. Inside here it says the union of B and C, B or C. But then I have the apostrophe here that means it's the complement, meaning not the union of B and C. So let's start by highlighting the union of B and C. So that would be both of these circles like this. Okay, this yellow zone that I've just created represents the union of B and C. Now it's appropriate that I've left these opaque and you can't see the numbers that are behind here because the apostrophe, we want to do not B union C anyway. So we don't actually want the numbers that are in this union. We want the people that are not part of this union. And so that's the 11, the only number that you can still see now that I've covered this up. So the 11 represents the people that are not in the union of B and C. Okay, now let's emphasize the difference between just writing the number, or should I do a probability where I'm going to do 11 out of 58? Alright, should it just be 11 or 11 out of 58? Well, it didn't say probability. There's no P in front of here. So that means this is just asking for the number of people. So this is simply going to be 11. Alright, not 11 over 58. I think I'll put it over here though. I'm so silly. Okay, it's just 11. Alright. Now, what about C? Set C represents the coupon users. That includes the 29 and the 8. So, of course, that is 37. Okay, pretty simple. Now, for this one, C and not B. Alright, the intersection of set C and not B. So for the intersection, we want the overlap between these two things. We want the number of people that satisfy both of these simultaneously. So there's a couple ways we could do it. We could just go in order and say, okay, let's start with the people that are coupon users, because we only want to deal with them for sure, coupon users. Okay, so the coupon users are these people and these people, alright, are coupon users. Okay, now we want the people that are not bag users, alright, because of the apostrophe, not bag users. We want them, that we have to, it has to be them as well, okay, simultaneously. But anyway, let me just highlight that. Not bag users. Well, the 8 and the 10 represent bag users. So the people that are not bag users are the 29 and the 11. Okay? Now, we want the intersection between those two groups. Alright? We want the people that are coupon users and not bag users. Well, my coupon users we highlighted yellow. My not bag users we highlighted in blue. So, who are the people that we highlighted twice? That would be the green people over here now. Okay? These are the people that are coupon users and not bag users. Alright? The coupon, in other words, the coupon users who are not the bag users. Alright? We are disregarding the 8. So it's the 29 that's going to be the answer. Alright, for these next couple ones we do want the probability, so we will be dividing target over total. So the probability of B, bag users. Well, my bag users are the 8 and the 10. Okay, that's 18 bag users. So that's my target. So I'm talking about 18 out of a total of 58 people in the survey. So let's just reduce that. So 18 out of 58. Alright, that's 9/29ths. Okay, so we could call that 9/29ths. And we could express that as a percent if we wanted to by toggling. So that's going to be, if we move this decimal point twice, okay, and cutting it here, that's going to be 31.03%. Okay, so that's D there. Now how about E? We want the probability of the intersection of C and B. Okay, the intersection of C and B is this overlapping part right here in the middle. It's the 8. Okay, so probability makes this 8 out of 58. Okay, so 8 out of 58. That reduces to 4/29ths. Okay, and I could make it a percent if I choose to. Okay, so this is going to be, move the decimal point twice. Alright, I'm going to want to cut it here. So that's 13.79%. And I won't round up because that's a 3. So 13.79%. Okay, so that's E. Is there an F? Okay, that's it for that set of problems. Let's see. Roswell North Elementary took a field trip to the world of Coca-Cola. The probability that a student likes Cherry Coke is 0.68. And the probability that a student likes Minute Maid Fruit Punch Lemonade is 0.43. The probability that a student likes both Cherry Coke and Minute Maid Fruit Punch Lemonade is 0.30. Are the events liking Cherry Coke and liking Minute Maid Fruit Punch Lemonade mutually exclusive or overlapping? Explain. Well, this kind of question doesn't require any calculations because it's just given to you in the problem. If they're overlapping, that means there would be a group who likes both, or there'd be a group that satisfies both criteria. So let's see, the probability that a student likes both Cherry Coke and Minute Maid Fruit Punch is 0.30. So 30% of the elementary school children liked both. So right there, that's your overlap. So there you go, overlapping, 30% of the students liked both. Now part B, if a student is randomly selected, find the probability that a student likes Cherry Coke or Minute Maid Fruit Punch. Okay, so to answer this question, you have two choices. You can either make a Venn diagram and do it just like we did up here, okay, in problem number 2. Or you could use the formula. Now here are some useful formulas which I actually gave at the end of this test. But so the one that applies is this one right here. If I can I get this? Let's see. Because it talks about the probability of one event or the other. So let me cut and paste that. Okay, we're supposed to be finding the probability that a student likes Cherry Coke, and we'll call that event A, or Minute Maid Fruit Punch Lemonade. which we'll call event B. Okay, so we're supposed to find the probability of A or B. But look, that's what this formula is for, the probability of A or B. So, according to the formula, that's going to be the probability of A plus the probability of B minus the probability of A and B, the overlap.
Daddy, do you want to go to Cracker Barrel?
I already ate, sweetie. But you guys go ahead. Cracker Barrel. My mom's in town, and you know, she hits every Cracker Barrel in the country. So that's what that was. Anyway, so the probability of A. So looking back at the problem, what did they say? The probability that a student likes cherry Coke, all right, that's our event A, is 0.68. Okay, so that means we've got 0.68. Now let's see, do we have probability of liking Minute Maid? Alright, the probability that a student likes Minute Maid fruit punch lemonade is 0.43. Okay, so this is our event B, and that's 0.43. Alright, 0.43. Now we're supposed to subtract the overlapping part. Do we know the probability of them liking Coke, cherry Coke, and the lemonade? Let's see. The probability of, I guess I got to scroll back. The probability that a student likes both cherry Coke and Minute Maid fruit punch lemonade is 0.30. So they gave us the overlap right there. They gave us the probability of A and B is 30%. And, you know, I guess we already wrote that down ahead of time. So 0.30. So we could just straightforward just use the formula to answer this question. So let's do that. 0.68, 0.43. That's 0.81. Or 81%. Okay? So, because I know the formula, I would tend to do it that way, because it's, you know, to me it's the quickest way to set this up. But if you were not comfortable with that, another way is to use a Venn diagram. Okay, so here comes our Venn diagram. So I'll use this circle to represent the people that like cherry Coke. I'll use this circle to represent the people that like the lemonade. So the probability that you like cherry Coke, that was 0.68. Okay, so I'm going to temporarily put that right here, 0.68. The probability of liking the lemonade, that was your 0.43. But the overlapping part is probability of 0.30. Now, I cannot put the 0.68 out here by itself. Alright, the 0.3 and whatever goes out here has to add up to 0.68. So I need to subtract 0.68 minus 0.30. And if I do that, I'm going to get 0.38. Okay. So again, these two together add up to the 0.68 that we're talking about. Same thing over here with the lemonade. I'm not going to put 0.43 out here. I need to subtract the 0.30. So that's going to leave 0.13. Okay. So now that we have our Venn diagram set up, Now, so if we're supposed to find the probability of liking Coke or lemonade, it's just going to be all of these probabilities added up. We don't need to divide by the total because these are already probabilities. They are already out of 1. Or as a percent, they're already out of 100. So all we need to do is add these up. So 0.38, 0.30, 0.13. 0.38 plus 0.30, of course, is 0.68. So it's really just, if we're just doing the math in our heads, we've got our 0.68, and now we're adding on the 0.13. So that's going to be 0.81. Okay. All right, 0.81. So there it is. The probability is 0.81 or 81%. So that's how you could do the same problem using a Venn diagram, or you could use the formula. Number 4, 2 number cubes are rolled. These are sometimes called dice, yo. Their sum is calculated on the following table. You get it, right? 2. If you roll a 2 and a 3, then that's a sum of 5. So these numbers are sums. Find the following probability. So, find the probability that the sum is greater than 4. So, how many of these numbers are greater than 4? Well, the numbers that are greater than 4, the sums that are greater than 4 are these. All right, I don't know what's up with the black bars covering up my screen. They are annoying me. Okay, so all of these numbers are greater than 4. Okay. So 6 by 6. This is a 6 by 6 grid. That means there are 36 possibilities. So I'm trying to avoid counting up all the numbers I just highlighted. So the quicker thing to do is to subtract the numbers that I did not highlight from 36. Okay, so I see that that's 1, 2, 3, 4, 5, 6. So if 6 of them are unhighlighted, that means these must be 30 highlighted. So there are 30 numbers, 30 sums greater than 4. Okay, so the probability then is going to be calculated by doing 30 out of 36. All right, that is 5/6. Which same thing as 83.33%. Okay. Find the probability that the sum is 2 or the sum is 8. 2 or 8. Okay. Alright, there's a sum of 2, and here's a sum of 8. So, how many of those are there? 1, 2, 3, 4, 5, 6. So that's 6 ways to win. So that's 6 out of 36. Alright, of course that is 1/6. Which is 16.67%. Got to round up. All right, now find the probability that the sum is even or less than 6. Okay, even, okay, would be these, even, or less than 6. So in addition to the ones I have highlighted, I'm also going to highlight these because they are less than 6. So when you do OR, you keep everything that you're highlighting, not the overlap. Alright, again, I'd like to avoid counting up every single highlighted number. So when I did the yellow, when I highlighted the even ones, the evens are half of the sums. Alright, so half of 36 is 18. Alright, so when I did the evens, that was, there were 18 of those. Then in addition to that, I had a few more that were less than 6. A few additional ones that were less than, less than 6. And those were, how many of those? So I'm just going to say like other. So we had 1, 2, 3, 4, 5, 6 additional numbers. Okay, so that's a quick way for me to add up and figure out how many numbers I just highlighted. So 18 plus 6, that's 24. So I've got 24 out of 36. It will be my calculation. Alright, so that's 2/3. Which I know is 66.67%. Okay, there you go. Alright, so that's it for part C. And you know what? That's the end of the first page. Alright, we have 3 pages on this test, and we finished page 1. Okay, so this would be a good place, I think, to go ahead and stop this video. We will pick up on the next video. Let's see which problems are coming up. Alright, our next problem is going to be a triple Venn diagram. Okay, and then we have some more Venn diagrams coming, and we have a table problem. So that's what the part 2 of the video is going to look like. So if that looks interesting, I will see you on part 2.